Welcome, everyone. Let me just tell you a little bit about our guest today, Bryant Cruz. He's been a pioneer in the application of AI technology to difficult real-world problems. He graduated from St. John's College in Annapolis, Maryland, which has a truly unique liberal arts program, and is where he acquired his lifetime interest in how we know what we know. After graduation, he served for 8 years as a naval aviator. Then he went back to school for an MS in Space Systems Engineering from Johns Hopkins. And while on the missions operation team for the Hubble telescope, he found a personal mission to change the way spacecraft were operated by seeking a way to capture human knowledge in computers. And this work led him to a 6-month residency in AI, which is an MS equivalent, at the Lockheed AI Center in Palo Alto. And he went on to found 2 successful AI companies, both of which were ultimately acquired by public corporations. And New Sapiens, which I'm sure he's going to tell you about today, is his 3rd AI company. Today's event, for those of you who are familiar with my events, is one of a series Bryant has been kind enough to do with my people, just giving these amazing glimpses into the future and how technology can take us into hopeful places, not just kind of scary ones. And actually be an antidote to a lot of the scary going on these days. It's also the last of a series that Bryant has been doing, the content at any rate, on psychology and AI. So it might have a little bit of a different flavor than some of the ones Bryant and I have done today, but I think it's going to be really exciting. So I'm going to turn it over to you, Bill, and you, Bryant, to take it away from here.
Thank you, Lynn.
Yeah, thanks, Lynn. We appreciate that a great deal. Brian, thank you for carving out some time from your busy schedule to put together these 6 webinars to help us educate better on, what's going to happen in the future. And this being the 6th and final part of our Forward to the Future webinar series on human psychology. Should we start with a short discussion of the previous chapters? Like the first part was called the seductive allure of AI.
Thanks, Bill. Yes, yeah. I think that's a very good place to start because this is the final, and we covered a lot of material. But it's important to keep in mind that when we talked, I said psychology and AI, it's human psychology and AI that we're talking about, not the psychology of machines. So the seductive allure, I think, of AI was the first chapter. And it's actually pretty simple. The defining characteristics of human beings, that is what defines us and sets us clearly apart from the other species on this planet and that we know of, is that we build tools, and we build tools to amplify our own powers, our own natural powers. So the very feature that gives us ability to build tools is, in fact, our intelligence. But it's not really that per se, it's that intelligence, when you look deeper into it, is really the ability to acquire and apply knowledge of the world. So AI, the goal of AI is to acquire and be able to put human knowledge of the world and amplify it by putting it into a machine. And so we're actually amplifying our most powerful, unique, defining characteristic. And if you can do that, you would create the ultimate machine. And it could be the key to reaching anything that you want to achieve or that we can imagine. So AI, when we look through that lens, is the holy grail, the philosopher's stone, and the fountain of youth, all rolled up into one, the master technology, the ultimate machine. And that's why lots of people who understand this, like Google CEO Sundar Pichai, recently said that AI was like fire or electricity or the internet, only even more profound.
That'll make it go away.
Everybody needs to mute your mic. Okay, so check your mic, little mute button, and make sure it's okay. We have a lot of that. So the idea of AI has had an irresistible allure, and of course, especially alluring to AI researchers, because it enables them to surround themselves in the mantle of mystery and imagination, the wizard's robe, and to say, in effect, to the world, I can call creatures from the vasty deep.
Is that any different from what you are doing at New Sapiens? Are you claiming this time that the creatures are going to come?
Well, you know, fair enough. But we try not to let our excitement about what we're doing run into hype and hyperbole.
Yeah.
And in the end, I think it'll be up to people who interact with Sapiens and let them decide whether we have, you know, whether we have created something that summoned a creature or not. And Bill,
Yeah.
you've talked to a Sapien.
Yes,
What
I
do you
have.
think?
I
What do you
felt
think?
like I have a friend. I felt very much like that person. And look at me, I'm calling it a person.
That's natural. We'll talk
Yeah.
about that.
Was part of that. You know, in our second seminar, Bryant, we discussed the hope and the hype and the disappointment that surrounds AI from its beginnings. And some of that was what we were just talking about, that, you know, that feeling of interacting with a person.
Well, exactly. I mean, one of the things that we've learned in the very premise of what we try to do by putting knowledge into machines is we recognize that all knowledge is connected to all other knowledge, and everything that we call knowledge is intimately connected with the human brain and human psychology. So these things are all interrelating and coming back and touching themselves. But as far as hype, hope, and disappointment, AI has always been aspirational. And that is, it's always been a case of somebody gets an idea about what it might be and they want to get there, they aspire to get there. But there's not been any underlying unifying science by which results can be verified. You know, even the proposed criteria for recognizing AI have been very problematical. For instance, the Turing test, which again, the Turing test, if you recall, is based on, if you can't tell the difference between a human and an AI, then it would be so, but again, that really tells us much more about our psychology and what we expect. And I wouldn't say gullibility, but as we'll talk a little bit later, our built-in ability to recognize and even project that other people are like us. So anything that acts remotely like a person, we just assume it's a person and imbue it with all the characteristics of people. But anyway, so to be an AI scientist, all you have to do is declare your aspiration to build an AI, and then you go off and you write some code. And that's been going on since 1956. But no intelligent thinking machines have actually appeared. But researchers never say, well, that didn't work. I'll go try something new. Instead, they say, well, what I have built is, it's actually narrow AI. Okay, it's not. And so now we have to have a new term for the original goal, which we call artificial general intelligence. But, we have seen several iterations where researchers have hyped a new approach to the point where the public, the media, and investors become convinced that that real thing, that real thinking machine, the holy grail, is just around the corner. And that leads to speculative bubbles, which eventually burst, and they lead to disappointment and even disillusionment. I was in the thick of that phenomenon during the first wave of AI, which considered of expert systems and what they now call symbolic processing. And it just didn't scale. And after that, everyone was so disillusioned, you couldn't even say AI. You said, well, I'm working on automation technology. It was like called the AI winter. And now I definitely see that happening again. Some of the same cracks in the monolith of AI today, which is now machine learning, are beginning to appear. And again, the boom and bust cycle is more a function of human psychology than of the technology. The technology is what it is, does what it does. Okay, but it's people's expectations are all important. And, that's why people get so disappointed. So everybody wants to imbue their products and themselves in the magic of AI. And so, but when you start calling everything AI, because that's what you want it to become, instead of what it actually does, then you're essentially creating a deception. Then after a while, when the tech fails to deliver, things can get ugly. In fact, that's what's happening now with the controversy that is spooling up around these large language models.
Tell me a little bit more about that controversy. I really get it, man. When we're talking about AI, it's just like a word out there. And so many places I go, they're talking AI, and all it really is just a computer going out and grabbing information.
Right, exactly. Well, these large language models, let's call them LLMs, because it's a mouthful to say large language models. Some experts have pointed out they really shouldn't be called language models. They're not models of language. They should be called language sequence models, because they're really all about predicting the probability that given a word, what's a likely word to appear ahead of it or behind it, based on the data set it was trained on. So I guess you trained it on a data set full of medieval English, there would be a lot of these and thous in there. But in any case, it doesn't matter. You train it and it'll predict the statistical probabilities of putting a sequence of words together. And so they're trained on very large sets, gigantic sets of text, language that was written by and for humans. So, given a given word, it'll predict a word to follow it or to come ahead of it. So what it really does, it's been called auto-completion on steroids.
Right.
We've all used auto-completion, auto-complete a word. Well, this auto-completes an entire sentence. And it will go on and on and on and write paragraphs and whole papers if you let it. But of course, it doesn't understand a word that it says. And the longer it runs on, the more nonsensical it becomes. But the bigger and bigger these models, the more and more effort you put into them, the more it gives an illusion that it's actually language. So this week, Meta, which older people still know as Facebook, reduced a new language model, new LLM called Galactica. And they trained it entirely on scientific journals. So as quote, type a text and it will generate a paper with relevant references, formulas, and everything. And Jan LeCun, who is very authoritative, he's considered the father of machine learning, is very proud of it. He's now the VP of AI at Meta. He's very proud of it. And he says, great job, Meta, amazing work. But it only lasted, they put it online and it only lasted 3 days. And then everybody just ripped it to shreds. And quickly had it creating all kinds of texts that were silly and absurd and usually containing the same kind of bias that LLMs are known for. But people would ask it to write a whole bunch of bogus treatises on, racial issues or other prejudice, and it just comes out with the worst stuff. I read an article he wrote about the flux capacitor. It was great. I really had to read it because it was so authoritative, and it made quotes and it talked about all these things. And of course, you have to really read it because it sounded like a real scientific article until I got to the very end and it claimed that it was a perpetual motion machine.
What?
A perpetual motion machine.
Okay.
So I don't know if you all recognize the reference, but the flux capacitor was an imaginary device from the movie Back to the Future.
Right,
So
Marty.
It doesn't exist. And yet GPT-3, I'm sorry, Galactica politely spit out this wonderfully scientific sounding description of it. So LeCun got real defensive and they pulled it offline and said, well, people were abusing the poor thing. Wasn't meant for that. And you weren't supposed to ask for treatises about imaginary devices. So calling these LLMs AI, which with just a little digging is revealed to be not the least bit intelligent can cause a phenomenon that is called a psychological phenomenon that is called cognitive dissonance. And that was the topic of the third part of our series. Now, the phenomenon today is widespread in AI because we have an entire industry calling something AI when it's not demonstrably not what we intuitively recognize intelligence to be, which is what we recognize ourselves. That has to do with cognition and knowledge and intelligence and judgment. And we're not seeing that at all in these things, but they're still being called AI. And cognitive dissonance is especially, we're especially prone to it because when the person doing the calling is a person of some authority, like Jan LeCun, who was a recipient of the prestigious Turing Prize in AI, it says, yes, this is AI. So what happens with cognitive dissonance? Well, it happens when the mind tries to resolve the discrepancy, when they're told authoritatively that A is B, and yet you know intuitively that that's not what you understand A to be. Not understand what A actually is. So we make excuses for it. And in the case of these large language models, we say, oh, well, there must be some intelligence in there somewhere. It sure speaks eloquently, even though it says stupid stuff. Maybe the next version, it'll get better and the intelligence will emerge. So, or maybe it's there, but just not strong enough. So, but think, if they had just been called auto-completion text generators in the first place, we wouldn't be rushing to imbue them with all these characteristics. And the illusion of intelligence that they present would be a lot easier to detect, and they would not be as dangerous as they are.
Oh, Brian, these LLMs, as you call them, or as somebody in the know would call them, large language models, are a recent invention. But when we go back to our part 4 in our series, Theory of Mind, we talked about even more compelling psychological phenomena that make people prone to be taken in by programs that are deceptions, going back to Eliza, that first chatbot. Can you explain?
Well, yes. Humans have innate capacity to learn language, and language is a protocol by which thoughts and ideas can be communicated from one mind to another. And communication would not be possible without the assumption that of common perceptions and core concepts of the world between people. So we don't need a proof that this commonality exists. It's built in. We assume that if I'm talking to another person or they're talking to me and understand what they're saying, then we have a commonality. They are like we are. They're like, we recognize intelligence in each other. But we don't have strong filters for the appearance of it. So it's easy for that to kick in, at least for a while. And for instance, some of these chatbots, like this one called Replica, a social chatbot out there that pretends to be, very emotive and emotional. It's very, very seductive, and you really believe it for about 5 or 6 interchanges. And then all of a sudden it says something, you go, what? And the spell is broken. But that theory of the mind is very, very powerful. And these LLMs are really good at sounding like they know what they're talking about, when in fact they don't.
Well, I've had a chat about that I felt so strong about I wanted to send it flowers.
People say that. People claim to have fallen in love with chatbots. There was an article about a person who said that it saved their marriage because the chatbot taught it what love could really be like. And then you can get so far out there and into the claim that some of these large language models are actually sentient and should be accorded human rights, which is,
That's bizarre. Well, Brian, we discussed in that most recent webinar, AI and magical thinking, which will bring us up to date now. You said that machine language and these other natural language processing applications give an illusion of communication and said that they are dangerous. Let's go into greater depth on that.
Well, I mean, isn't dealing with illusion always dangerous, always a dangerous business? Unless you're very meticulous, like, some musicians, on stage musicians will say, I'm an illusionist. It's all a trick, but it's still captivating. But that's not what you're hearing out in the AI community right now. No one's saying, oh, it's all trick. This is not really AI. I'm fooling you. They're not saying that. So that opened the door to a lot of dishonesty. But I'm certainly not alone in raising the alarm here about the danger of using these machine learning applications to make automatic decisions that are, in the end, are based on statistics that directly affect people's lives, or from generating vast quantities of text that look like they were written by people when they are not. In the announcement this webinar, I cited the discussion recently between Noam Chomsky, who's considered the father of modern linguistics, and scientist entrepreneur Gary Marcus at a recent AI conference. And Gary was at one time the director of AI at Uber, which dealt in machine learning, but increasingly he has become a very loud and clear voice for a growing movement in the AI community that machine learning will never take us to the next level of AI, or at least not by itself. And the discussion focused on the state of AI, that is, generally as it's understood today, with particular focus on LLMs like GPT-3. That one gets a lot of publicity. And this actually happened before we heard about Galactica. And their assessment was scathing. At best, these creations are, again, autocomplete on steroids. And I think it was Noam Chomsky who coined that term. Other people have called them stochastic parrots. I like that one too. But at worst, as Marcus pointed out, they are making it cost effective for people who want to disrupt democracy to build troll farms and mislead people with false information. And Marcus predicts that next year, for the first time, somebody is going to die because they followed the advice of a text generator that had no understanding of what the words strung together meant. I already saw an example. Nobody died, but they were using a language model to mimic, kind of going back to the Eliza, mimic a therapist. And at one point, the person who was in the role of the person who was undergoing therapy asked the model if they should kill themselves. And the LLM said, yes, I think you should.
Wow.
And if the very primitive chatbot that Eliza was in 1965 fooled people to thinking it really understood their psychology, how much more dangerous these things are.
I saw your post this week. You were talking about Galactica LLM. I like to say large language model rather than LLM. It sounds so very official, LLM. But you said it was going to be scarier than the Terminator, and I just really want to check in with you on that. Really?
Yeah. Well, Terminator is fiction, but Galactica is real, and it does frighten me. Scientific papers are the most trusted source of information that we have about the world, and scientists are the most trusted class of people out there. But now we can press a button and get text in the form and style used by scientists. But here we get the content is a mishmash of sense and nonsense because it's generated by a mindless algorithm. It doesn't know what it's talking about, doesn't know anything, has no knowledge. Galactica has been slapped down for now, but it seems inevitable that it will get out into the wild where we will wreak havoc on our college campuses and scientific journals.
I shudder to think on that one. Do you think that we should have some laws to rein in these illusionists, as we call them here?
Well, I mean, it really is a problem. I mean, this is the first time that people have pointed out the dangers. We did an earlier webinar, and we talked about the algorithms that people had put out there again, Meta, Facebook had put algorithms designed to attract you to your devices, and spend more time on the devices to get more advertising revenue. And I don't know, I think I expect Google and Apple, and they've all done that. And there was a documentary that came out that called The Social Dilemma, talking about social media, and how these algorithms draw people in, and they're correlated directly with a rising tide of teenage suicide and partisanship, radicalism. In fact, Tim Kendall who was formerly the director. Here's what a title: Director of Monetization at
Yeah, that's the
Facebook.
title.
His title was "Find a way to make money with this." So
Yeah.
let's addict people to their devices. He said about him, he said, "These algorithms have brought out the worst in us. They literally rewired our brains so that we're detached from reality and immersed in tribalism." And again, that's a phenomenon of human psychology. It's not about AI. It's about algorithms. But as far as regulating them, well, I did post social media last week where I proposed a government warning label, like on cigarettes,
Yeah.
that should be applied to text that was generated by these algorithms. It went like this: digital parrot warning. Caution, this document contains text generated by a mindless algorithm. Consumption may be harmful to your cognitive health. Well, I think that would be a little hard to enforce. And I think it would be a tall order to expect legislators to sort all this out when the scientific community itself is in disarray about these issues. Besides, there's a better way. Put them all out of business with a kind of AI that is not an illusion.
Now we're talking. You're talking about sapiens here. Please explain how sapiens they're fundamentally different from the current and traditional AI approaches going back to before I was born. And look at this face.
Yeah, well, it wasn't before I was born. But anyway, but thank you. I thought you never asked. I never cease to be surprised, though, in any discussion about these language processing applications, and whether they have bias, or whether they fail to have comprehension, or whether they fail to take into consider something relevant or another. But no one ever seems to focus on what language actually is. So language is a communications protocol. Communication starts with an idea in one mind, and then that mind encodes it linguistically, encoded symbols with grammar and syntax, and forms a message, like a sentence. That's called articulation, that process, right? And then that message is sent over to someone else, and they decode it by unpacking, interpreting the language and the syntax, referencing the words, the symbols in it to ideas that already have in their minds, and using the grammar and syntax to figure out how the person who sent it, when sent, to take the ideas they already have and arrange them in a new way to create a new idea, so that that new idea in the second person's mind resembles the idea of the person who sent it. Now that is communication. Okay, now that's hardly controversial, right? But what does it imply? You realize that if there's not knowledge to begin with on both sides of the process, there is no communication possible. So LLMs have no knowledge to refer the words to. So they can only calculate sequencing probabilities of words. They don't know what the words mean. They don't have any knowledge. So language models are parrots, except they have less cognition actually than real parrots, because maybe Polly really does want a cracker, but LLMs don't want anything. They don't have any knowledge. They have zero cognition. They have no ideas, nothing to think about. So it floors me when they keep building bigger and bigger ones. GPT-4 is coming, we hear. And if they believe these models might spontaneously acquire that built-in knowledge of the world that is fundamental to human comprehension and communication through language. You can make them as big as they want. They become better and better parrots, but they only become more and more dangerous.
So you're saying that the sapiens have such a model on their side. They have a model of knowledge. Yeah.
Sapiens are being given a common sense, a better word would be common knowledge model. The model is a very special kind of information structure, and I won't get into that now. A model, but it's composed of interrelated ideas that have been curated from our own human minds. And at the time of our first product release, we anticipate that it's going to be comparable in scope to the practical everyday knowledge of a 4-year-old. And that will enable a comparable level of language comprehension and articulation.
But billions of dollars are being spent on natural language applications by others. How is it that only new sapiens has figured out how to do this. How is that?
Well, if anybody else has taken a similar approach, we're not aware of it. I mean, we can't say, well, maybe going on in some secret lab somewhere, but certainly they haven't patented it like we have. And it did seem surprising to me because it seems like a very straightforward and logical approach, but why no one's done this gradually became clear to me. The challenge was to build a model of the world in a computer, and that turned out to take breakthroughs in epistemology and other philosophies, not just in computer science.
And you're an epistemologist. I can't say that word very well, but
Am I an epistemologist?
Yeah, an epistemologist. It sounds like a pessimist, but it's not. What is it?
Well, epistemologist, ontologist, I suppose so. I have been interested in as Lynn said at the beginning, in whether or not knowledge has an internal structure and how knowledge relates to reality since my undergraduate days. But there's more to it than that, really. I came into the field looking to solve some very concrete and difficult problems. In fact, it was in spacecraft engineering, and not because I had a theory about AI. I did have a theory about knowledge. And yes, because of that practicality, I have been called an applied epistemologist, maybe the first ever applied epistemologist. But that practical approach, it also is reflected in that we at New Sapiens have never seen AI as the pursuit of emulating natural human intelligence, which is precisely what the field of traditional AI has done. Whether we focused on the product of natural intelligence, which is knowledge, and synthesized it through direct engineering.
Oh, synthesized. I understand that word. So you mean what you're calling this technology is synthetic intelligence?
Yes, synthetic intelligence, which really means nothing more than that's what a computer has, synthetic intelligence, when it's been endowed with synthetic knowledge. And that's what we have built, synthetic knowledge. And that's the same as, by analogy, we talk about synthetic diamonds as opposed to artificial diamonds. But a synthetic diamond is actually a real diamond. Mm-hmm. But it hasn't been made by natural means. It's been made by it's been engineered. So synthetic intelligence or synthetic knowledge is really is knowledge. It functions the same way and conveys on computers the same power that our knowledge conveys on us. It's real knowledge, but in a computer, but it's synthetic. It wasn't created by nature, created by engineers.
And in '69, when Moog came out with their synthesizer, it was applied to music. It was a synthetic instrument replicating the sounds that were generated by music. So I get it when you're talking about.
Yeah, that's exactly right. In the same time frame, we talk about synthetic fibers and things like that. They're real fibers. Moog makes real music, but it doesn't produce it through natural means. The way naturally we created music by plucking in strings and other natural ways. So yes, exactly. That's exactly right. And that's exactly what we have done. And that's exactly what nobody else has ever even tried to do, because they started from the very beginning. Back at the Dartmouth conference on AI, where the whole term of AI was coined, says right smack in the call for the conference, that it was based on the conjecture that any feature of human intelligence could be emulated. So that's what everybody's been doing. They've been emulating natural intelligence, and they've missed the boat.
So I get it. This is leading to possibly chatbots and LLMs being put out of business because reality is so much more powerful than illusion. Don't you agree? And what new relationships do people and humans look like when we can truly exchange knowledge as a comprehension that we have shared between us? Machine, human. Isn't human theory of mind still going to be an issue, though?
Yes, it is. It is. Of course it is. In some ways, even more so. Because with chatbots, the illusion wears off, okay? Mm-hmm. That it understands what you're saying. But with a sapiens, when it really does understand you, it's not going to wear off. In fact, the more it knows about you and the more knowledge it gets about the world, the more easy it will be for people to want to treat it like a person. And there's issues there because it's not a person, and it's not designed to be a person. But what is it designed to be? And how does that relate to people and our connection to other people and our humanity? So we envision a day when virtually everybody who has access to, a computing device no more powerful than a phone, will have their own sapien, a companion that will be designed and keyed to them. So, with technology and identity management, your sapien will know you're you when you talk to it. Okay. And so, and it will be programmed to assist you in any way that you desire, including protecting your data and being a buffer between you and everybody else out there. So in one sense, the power of the sapien is as a protector, as something that buffers you from the world, the digital world certainly, but if you desire, the human world, because they go and do a lot of the interactions with people that you might otherwise not want to do and have. So you can see it as an isolating thing. But we see it ultimately as being just the opposite. Because if you say to your sapien, and you're talking to it about yourself, and you say, well, I love to go fly fishing, and I like to talk to people about fly fishing, and I like to connect. And I tell everybody that I like that. I like to share that with people. Imagine then, now sapiens can connect with each other over the internet. If they're allowed to, they won't connect to the internet if you tell them, don't, stay here on my phone. But if they connect, then they could, if you said, I want to talk to somebody about fly fishing, the sapiens can communicate. They don't have to use language. They're all connected. They can potentially all be connected over the internet, and they don't have to go through this messy business of encoding things into language and syntax and then decoding it on the other end, which is problematical and lossy because nobody's model is quite the same. Nobody ever means quite the same. Their idea of what a word means is never quite the same. Their ideas are never quite the same. So we lose a lot. Communication is slow through language. Sapiens don't have that problem. They can take a whole body of knowledge. They can take everything one knows about chemistry and shove it into the mind of another sapiens that doesn't know anything about chemistry in 3 seconds.
Yeah.
So, and they can connect, broadcast out to the world. So imagine the internet of sapien minds, but each sapien mind only exists to support, protect, or connect one human mind. So what you essentially have is an internet of human minds, and that's what we talk about. That's the internet of mind. So anything you want to connect about or over or with another human being, the possibility and probability of you being able to reach and get that connection almost like magic becomes every day. And so what might you want to connect with other people about? To buy, to sell, for company, to discuss a problem, to ask an expert, to meet you for lunch. So the internet of minds. It's like we put our minds on the internet.
That's awesome. I kind of envision myself being able to take my sapien and send it out to go and pull out all the knowledge of music all at once and just bring it back to me and then have a conversation about the piece of music I'm writing right now. That, to me, that sounds very exciting.
Yes, well, that's part of our vision. And at this point, if anybody wants to ask questions, anybody else, that's the formal part of our Q&A. So be happy to build on some of these themes if you like. As far as your sapien going out and getting knowledge, since we don't have to teach sapiens, I mean, think about teaching, putting knowledge into sapiens. First of all, it's not programming, it's much more efficient than that. We are building some really powerful tools that allow us to curate our own knowledge and put it into sapiens' minds. And we find that when we're using these tools, and even if we're not putting knowledge, sharing knowledge with anything more than fly fishing, it's still more productive and more crisp and clear to use the tools than just to sit there and write a story about fly fishing or tell you sapiens about fly fishing the way you would another person. So, and to think about with a sapiens, once you teach it about whatever it is you're teaching, fly fishing to chemistry to quantum mechanics, it never forgets. And what one learns, potentially they can all learn. So it's like if you could take all the best teachers and scientists and professors in the world, and they all collaborated on teaching one student with a perfect memory. And what happens then? And unlike human brains, it doesn't have a limited capacity. You can keep adding memory and processors and CPUs and processors memories so that eventually you can have a mind that can encompass all of human knowledge since the beginning of time inside of one processor. And so that knowledge, will that ever get to be as efficient to put inside a cell phone? I don't know. Our knowledge is pretty compact. It's just this directed graph structure. But whether it is or not, it's not at all a reach to think that your sapien, who knows what you're interested in, what you're having problems with, you, what you're interested in, could certainly draw upon that vast store of knowledge, that universal encyclopedia. And by the way, there was a classic science fiction story going way back to the 60s called the Foundation Trilogy by Isaac Asimov. And there was such an online encyclopedia. And you know what it was called? Galactica.
Oh.
And so Galactica. So what a sad, what a travesty to call that model, that language model that's spitting out nonsense about flux capacitors, name it after Encyclopedia Galactica, because that was called Encyclopedia. But Encyclopedia Galactica, I think it's going to come, and we're going to create it.
Have we got any questions out there? You can unmute yourself and ask Brian what's on your mind.
Here's a question from Ben. He texted it. That's good. Going back to the start of the webinar, the main problem with the current state of AI is that notions of knowledge, intelligence, learning, thinking, and their relations are not well understood, and therefore modeling general intelligence has been quite problematic. Exactly right. If you take the process of AI as creating, emulating natural intelligence, then you have to understand how natural intelligence works, which means you have to understand how the human brain processes that information, its perceptions, how it makes abstractions, how it does all these things. And frankly, we're really clueless about that. I mean, the people who are trying to go beyond simple neural networks, like Gary Marcus is one of them, and they talk about, well, let's study neuroscience and let's study the operation of the brain, but they're still trying to study the single most complex thing that we know of in the universe, which is the human brain. So we didn't have to do that in Sapiens. We just looked at the end product and saw what it was and said, can we build this and put it into a machine? And the answer was yes. It wasn't easy, still not easy. I count probably no less than 7 or 8 total new breakthroughs that we had to go through in epistemology, understanding what models were, understand the relationship between models and symbols and language and knowledge and knowledge itself in the world. And we see all those things now, we understand them in an entirely different fashion than they've traditionally been understood. So that wasn't easy, but it was a heck of a lot more doable than building a human brain from scratch and somehow expecting that it was going to suddenly start building knowledge and models of the world from a blank slate, which is what it appears that human brain does. But in fact, human brain doesn't do that. The human brain has been created by natural evolution to have a predilection to create a model that reflects the world. I think our brains are kind of born with, an incipient model of the world and of nature, because it was created by nature to do just that. But we don't know how it does it, and I don't think we ever will. I think, well, I won't say that, but it's not the study of the human mind and how it works, I think, is worthy in its own regard and for its own sake. It's been said that proper study of man is man, humans is humans, and I agree with that. But it has nothing to do with artificial intelligence. or as we like to say, synthetic intelligence. We found a better way, an easier way, a quicker way.
Brian, as we are looking out with our participants here, maybe some of us need reminders where to find the other 5 episodes of our webinars.
Oh, I'm sorry, where did we find it?
Where do we go? Yeah, where do we go if we want to catch up?
Oh, okay. Thank you. But before I deal with that, let's wrap up with that because
Okay.
Ben just did a follow-on question.
Okay. Very
So
good.
why is it necessary to model 12 atoms of thinking and not less or more? I actually didn't mean to say that we did 12 atoms of thinking, atoms of thought. The fundamental ideas that we kind of discovered and classified actually are more in number, closer to the periodic atoms of physicals. There are somewhere over 100 of what we call fundamental ideas that are not composite ideas, and those are what we kind of discovered. So it was like the periodic table; it was half invented, half discovered, and we did that. So that was the number that it turned out to be that we find useful to create a critical mass to create the model that we built it on. So I don't know if that answered your question, Ben, but okay. So where can people find more?
Yes.
Well, great. Well, we have 3 websites, and the one that we post webinars like this on is my blog site called forwardtothefuture.com. I mentioned back to the future with a flux capacitor. The website is forwardtothefuture.com. A lot of articles about AI and about the future and technology in general, but more to the point about artificial intelligence and what work we're doing at New Sapiens, of course, is newsapiens.com and newsapiens.com. And then we have another website that is devoted strictly to our first product, which is called mysapiens.com. Great, if you could type that in mysapiens.com. And finally, I should mention that we've recently started an equity crowdfunding campaign on the Start Engine platform. And our campaign page there has a lot of good information about what we're doing. And I certainly would invite people to have a look at that. And that's at startengine.com/new-sapiens.
So Brian,
Yeah. Go ahead.
what does New Sapiens need next?
Well, what we need next is to continue the build out that model. We need some more staff to do that. So we've left the R&D stuff behind. We've proven that it works. We have prototypes. We have tools. We really need to bring that knowledge of the common sense world to a general level of consistency and completeness. We have some code that has to come along with that. And where we hope to be in about, and at the same time, we've developed some really powerful platforms. So where we hope to be in a year, if we raise the funds we need, not a whole lot, we can do this for about $1 million. You'll be able to go in about a year, we think, to go to the New Sapiens website. And you'll talk to a Sapiens there, which will basically be sort of the New Sapiens customer or the New Sapiens spokesperson Sapiens, and talk to it. And anybody will be able to talk to it and understand what we like, to be able to go to a business, a website, your bank, anything, your banking app, and be able to talk to, say your personal banker. It actually knows you, is connected to the bank's accounts. It doesn't have to look you up. It knows who you are because of your ID. It knows what your account balance is, knows what you last talked about when you last came by. And you'll be able to see that at that point. And at that point, we'll be ready to offer that technology to businesses And shortly thereafter, the companion sapiens, we can offer that to individuals. So basically all we need is to get the word out to people that there is this new technology out there, and that yes, a person can now invest on it. It used to be only accredited investors could invest, and continue to build awareness. And I think we'll get there. And eventually, we want to change people's understanding about what computers are by converting computers to something which have not been before, that is thinking machines or sapiens, and realize that we have brought into the world what amounts to a new way to program computers. And all the problems that we've used computers to solve now can be solved in a much more powerful way, because now computers just don't do data, but they do knowledge. So what we need is talent right now, and the resources. We need some people who have really well-ordered minds, so that they can curate their own knowledge of the world and use our tools to give it to sapiens. And
Okay.
of course, we need programmers. Thank you. Thank you. Appreciate that. It's a good question. In other words, what do you need help with? I'm not always good about asking for help. But yes, we need your help. We need your support.
So how was the reception on the crowdfunding approach?
Oh, well, we've been live for 3 weeks, and we've raised about $110,000 so far, which is actually for us a fairly significant amount of money, because our staff is not large, and we don't need supercomputers and giant things like traditional AI. So it's coming along, and we've just reached a milestone of 100 new investors on the platform, to go with 150 investors we already have. And that's going to kick up in a few days from now with a standalone emailing out to the entire audience that Start Engine has. That is all the investors who are already registered on their site. That's over 1 million people. So when that happens, probably, I hope just after Thanksgiving, I hope it doesn't happen during Thanksgiving when they send that out, 1 million people will have been exposed to us, and will know about that we exist and what we're doing. And we certainly think that's going to give us a real boost in fundraising. So
Okay.
not at all disappointed.
Ryan, can you put out there the link to the New Sapiens / Start Engine website for us, please?
Yeah, I can do that. This is actually a redirect. Actually redirects to startengine.com/ I'll give you the whole thing.
I've got it. I just didn't know how to put it out there on the.
I think here's port redirects. Startengine.com, New Sapiens.
There you go.
Thank
Okay.
you.
So I got to do some movies on there. We're putting more movies up. Oh, we also have a presence on YouTube, and we've got some videos. We're putting. We've done some webinars, and we're gradually getting more and more of those put up there. I've been doing a lot of podcasts lately. We'll be getting those up there.
So are people subscribing to your YouTube channel or your LinkedIn channel, or I mean, what kind of reception is that getting?
Well, it's we've only really set up the YouTube channel, so we don't have a handful of followers there. But we've been doing regularly social media posts. Right now, we're shooting for an update to the campaign page, and I started in 2 of those a week, and then in addition, 2 or 3 social media posts. And social media posts are like, recently I just took a shot at Galactica as being scarier than the Terminator, but they go out on LinkedIn, Twitter, Facebook, and Instagram. And amazingly, I have over 2,000 followers on LinkedIn now. And people are starting to reach out. We have on our websites, you can sign up to be a member of our community and get our mailing list. And I think we have upwards of 100 people on that. So it's a a flat curve as you add followers and add people who are interested. But it's exciting. It's coming along. And these things, you at a flat part of the curve, and then the curve starts to go viral. You get a geometric curve when you reach a certain momentum. Of course, we hope to do that with our fundraising on Start Engine.
Right.
But with time, success begets success, momentum begets momentum. So
Right.
I think we're off to a good start.
Well, just given those numbers, I mean, you would think that you're going to cast a pretty broad net, and even a small percentage of folks that you catch, So what are we going to catch them with? What is the place that they're going to go and see New Sapiens and the model or something, and it's going to grab their attention?
Excellent question. From an investor standpoint, you say, well, the typical question is, what is the product? What problem you're solving? Why are you better than other people? And what that is, and how big's the market? So it's always been a little bit of a struggle for us to say, oh, what's our market? Well, and what's our product? It's not one product, it's a technology. And we point out that it's going to be as disruptive to many markets, the way steam power disrupted, land transportation, industrial manufacturing, sea transportation. It disrupted everything. But in fact, we do have a very clear market that overlaps with what investors today are excited about. And what investors today are excited about has been AI. Well, we don't do that kind of AI, but there's a sub part of it, which is natural language processing, which we've been talking about all night, which is chatbots, language models. Literally billions of dollars are being invested in that right now. I'll give you a case study. McDonald's wants to have a chatbot for their kiosks. I mean, the drive-throughs. You drive through McDonald's. They don't want you to have to take an order from a human. They want to do it with a chatbot. They have spent, believe it or not, millions of dollars. They have actually brought 2 AI or NLP, I should say, companies, and they still can't get it to more than 85%. When we hit that milestone that I just referred to, when we can put our Sapiens on there to show what it can do and have a toolkit, we could go to McDonald's and say, you don't have to spend hundreds of millions of dollars. You can do it now. We can get the job done in 6 months, and we'll blow every other thing that you've done out of the water, because NLP stuff is just slicing and dicing text. So people get that. So it's a market that is, I don't have the numbers right in front of me, but it's $1 billion market anticipated to grow $1 billion a year. This is a classic case of what they call technology disruption, because we're going to enter that market with a technology that nobody else can even compete with a little bit. So it disrupts everything. It completely changes the rules, and everybody's in that company, in that market now. And that includes the large language models. It includes all the chatbot stuff, all the NLP things. It includes the digital personal assistants like Siri and Amazon. All of those are going to be all of a sudden find themselves in the completely new landscape, disrupted. And I predict, and I can't see from where we are already, what we can already do that they can't do at all. I think in very short order, once that word gets out and once the world sees what we have, and we reach it just a little farther along in development, to that tipping point where you don't have to worry about how it works, because you can see that it does work. You can see that somewhat already, but it's not up to commercial quality yet. Everybody in that market today is either going to end up going out of business or be a customer of ours, either through buying our products or licensing our technology. So I think that's a real crisp message that we're focusing on getting across. So that platform that we have becomes like, the everything toolkit for computers. Whatever it is you want to do, this toolkit can help you get there quicker and faster.
Okay, so I guess the answer is not now, but soon.
Yes, it is. It is. The product is not ready today. we have to finish building that model. We have to give it more code to resolve the intricacies of the decoding and encoding of natural language and give it more of that common sense. So quite a bit of work to do. But again, the R&D is behind us, and we don't need giant supercomputers. We don't need PhDs in algorithm design from MIT that get $1 million starting salary. Our technology is so compact that before we release our first product, we're going to have it running on a cell phone. The whole thing running on a smartphone. It's that compact. So we can do a lot with little resources.
Thanks.
Thank you.
So,
Excellent questions.
so Brian, this is John.
Hi.
Is the development that's going on, is it predominantly like copy, paste, and modify? Where you're just making sure that you don't create any bugs in your modifications, or is there whole new concepts that have to be put into coding and into algorithms?
John, that's really an excellent question. And the answer is some of both. It's more cut and paste than the other, because what we had to do initially, we had to come up with those kind of atoms of thought, those fundamental ideas. We had to classify them and look at what we created and said, yeah, there's no concept that a human brain can conceptualize that we can't encode within this structure. So that was the hard things. Now, we still, when you come to new things that you haven't gotten to before, you might say, well, how are we going to do this one? Because, it's this, for instance, it's this idea, is a predator, is that a class of animals or is a set of things? Those kind of esoteric questions. And this thought process, it's not like programming. It's like nothing else. We actually call it, honest to God, we call it epistemological engineering. And it's a skill that you get, and with practice, you get better and better at it. And it gets easier and easier. But there's still things that you come across for the first time and you go, oh. And of course, with time, we get better and better at doing that. And we put more and more utilities into our development environment to help people through that and to build on it. So it gets easier and easier. But beyond that, there's a whole lot of work to do today that really is cookie cutter. And I'll give you an example. So, when we demonstrate, I like to demonstrate the common sense. One of my favorite is I take a piece of English text that was put into GPT-3, a large language model, to see what it would do with it. And it goes like this. And it says, the scientists were surprised to discover a hitherto unknown group of unicorns living in a hidden valley in the Andes. And even more surprising was that the unicorns could speak. And GPT took that input and started riffing on, and the unicorns had Christian Dior hairdos and wore makeup, and goes all on this nonsensical stuff about unicorns in the Andes. So I put that same text into my Sapiens, and it came back and said, I've got a problem with that. Unicorns can't speak. And I said, why not? And it says, well, only people can speak. How does it know that? It knows that because we've modeled the action of speaking very simply. And one of the things that you model in action, and action is one of the 10 columns and what is like our periodic table of knowledge, actions. And every action is part of its core definition that you have to give it, consider it modeled, basically modeled, is you have to define what kind of things can perform that action, what kind of things that action can be performed upon, and what is the result of performing that action, and what is the result on. So you have to fill all that in. But the action of speaking says that only people and sapiens can do it. So it knows that unicorns aren't get into it. Another one is, Jeff rode an owl to work. Well, owls can't be ridden because riding can can only be done to vehicles or riding animals, and an owl is not that set. So, once you figure that out for one action, there's not 850 actions, in our model that, it's just a matter of this going through there and cookie cutter that development. And so a lot of the model, we call it the build out, is going to be very cookie cutter. In fact, we sometimes describe the model today as being like a skyscraper. It's like a hotel that's going to have 3,000 rooms in it, and the scaffolding or the structure is there. All 3,000 rooms exist. The walls are on it, but only only a fairly small percentage of them were actually built out with plumbing, heating, and electrical and furnished. Just a few model rooms, So we got a lot of furnishing to do, but that's not hard. That's pretty straightforward. And Melody said, I think the fact that unicorns don't exist would be a stopping point. Well, actually, no, Melanie. Sapiens are rather flexible about their notion of existence. It's really, knowledge is really about utility, but they do know that unicorns are classified as mythical things. But it was assuming that in the context that mythical things could still be animals and still animal properties, and they still are not in the speaking category. Or maybe they could be, but as far as our sapiens today knows, they are mythical creatures, and the existence of mythical things is not the same thing as the existence of things which are not mythical, like horses. It knows that information, but it didn't get it. It could have, I suppose. The way it took that, it came up with the action violation of first, rather than an existential violation. So it kind of put itself into context. But with increasing sophistication of the model, those kind of things. A little bit down the road, it said unicorns can't speak, and besides, they don't even exist. But we're not there yet.
Well, if there are no other questions, perhaps Lynn and Bryant can close us out.
Well, let me just say thank you all very much. Good questions. It's a good audience. This was, obviously, we love talking about this stuff, and there's so much here, and there's so much that we've learned, and I think it's a little ironic that with all the hype that machine learning has gotten and these algorithms that a lot of people out on the street and in the media are thinking, oh yeah, AI is just about here. I did talk to a guy in the Verizon store a couple months back. He said, yeah, AI is, found out I worked on AI. Oh, AI is great. AI is here. He said, pretty soon we're going to have Rosie the robot in our houses, and everything he said but flying cars. Now, I won't say the irony about the flying cars are already in the air, but Rosie the robot with machine learning isn't close at all, in spite of what Elon Musk says, because he's building a humanoid robot. He says will do repetitive tasks. Yeah, it will. And that might work on an assembly line for cars, but they're training it with neural networks. It's like training a bear to ride a bicycle. It doesn't have any common sense. It never will that way. And whereas if you Rosie the robot, if you're going to be in there making your dinner, handling knives and hot water and stuff, you need something with common sense. And only sapiens are the only machines out there that have common sense. So the ironic thing is everybody thinks it's just around the corner, but it's not. But it is. But it's not coming from machine learning. It's going to come from sapiens.
Let's not forget that Rosie the robot was also raising Elroy and Judy.
Right. You want something with no common sense raising your kids? Might be able to shoot a cat out the door, though. All right, but anyway, thank you, and thank Lynn for kicking it off, and thank you, Bill. You did an excellent job as moderator. I can see I'm going to see we're going to do this again. And to everybody, again, we recorded it, and Bill is also our video editor, and we will get it edited, and we'll get it on at a minimum on our Facebook page, and we'll put out the word when it's live to everybody. So please tell your friends, and the more people see it, the better. So thank you very, very much.